Hello, everybody. So I'll begin to run through and actually the another set of method to producing context-free grammar, which is removal of unit production. So in this case, unit production can complicate the process of derivation in a grammar. Removing them will really simplify the grammar without changing um, the the language it generates. So making parsing and analysis more efficient. So what is unit production? A unit production is a rule in context for grammar where non-terminal symbol produces another non-terminal symbol. Like for example, A is producing non-terminal B, so that production is considered as unit production. So this production introduces unnecessary indirect steps in the rotation, which can be eliminated for simplicity. Say for example, B do have a derivation of terminal symbol as C. So therefore, we can remove B in under A and make it as terminal symbol with respect to what will be the value for the derivation of of the non-terminal B. Begin to deal that in a while. So why remove unit production? Unit production introduce an extra level of indirection by linking non-terminal to another non-terminal, and removing them will streamlines the grammar, making the derivation more direct and the grammar more concise. Of course, if you're able um, to remove those cases, we can definitely like avoid those ambiguous I mean, behavior or redundant or whatever. Now, there will be steps for removing unit production. Removing the unit production really involves identifying all the production, replacing them with the direct production rules, and then iterating until no unit productions remain. This process ensures the grammar is simplified while preserving its language. So the first step that we have to consider, identify the unit production. What will be the unit production under such circumstances? Start by analyzing the grammar to find all the production rules like the format A is to B, and where both A and B are non-terminal symbols. These are the unit productions that need to be removed. And then replacing unit production for each production A to B. Look for all the production rules where B appears on the left-hand side, such as B is to X, and this production rules there to A, by passing the intermediary non-terminal B. Now, how to remove that one, the original unit production? After introducing the new production rule, remove the original unit production like the A is to B. That will ensure that the grammar no longer contains indirect derivation and that all the rules are more direct. And then afterwards, we have to iterate the process, repeating the process over and over again, the same procedures after up until we were able to find the base case, for example. Repeat the process of identifying unit productions, replacing them and removing them until no unit productions remain in the grammar. And this will ensure that all indirect paths are eliminated. So considering that we do have here a specific example, but we have actually y is to z, since z is actually is to m and m is to n also, that is indirect. So n is to a, so that's not unit production violation. But we'll begin to I will begin to walk you through in a while. Let's actually finish the for this one first, the discussion. So why simplification matters? By removing unit production, the grammar is simplified, reducing unnecessary indirection. This makes the grammar more efficient for parsing algorithms and better for grammatical analysis. And then for removing production, unit production removal is a key step in simplifying context-free grammars, and this process streamlines the grammar while preserving the language it generates, making it more practical for both theoretical and practical application. And then removing unit production simplifies the grammar by eliminating unnecessary intermediate steps. It makes the grammar more direct, reduces the number of actions, and optimizes it for parsing algorithm. That is the advantages. And for disadvantages, while removing unit production, it will streamline the grammar. It can lead to an increase in the number of production. In some cases, additionally, the process requires careful handling as it involves multiple iterations to ensure no unit production routines. Afterwards, the application is removing unit production is widely used in compiler construction as it simplifies the parsing process. Then also critical and theoretical computer science for analyzing the structures, complexity, and context-free languages. So this is actually the end of our presentation here then, but allow me to go ahead and share my iPad so that we can illustrate some example on how to remove the unit production in step-by-step manner so that we will really understand how we can implement this our technique. Okay, thank you so much. Just give me a second to share my iPad. Okay, so we have here the specific data that we will be going to work on. So we have to identify the unit production first. What will be the considered unit production here? So here, y is actually given z, that is actually a violation. So y is to z, and for z is to m also, and then m is to n. We are actually given a relationship with the non-terminal symbol. Our goal actually is to solve that one. So z, what will be z? That is m. M, that is n. N, that is a. So therefore, we can divide this first. We can remove the n first. So since your n is equals to a, so therefore, for m is to n will become n because why? And the value of n earlier is 8. So therefore, your production rule will be updated into xy, and then x will be a, and then y will be z, will be b, then z will be m, and then your m is already a. And your n is already a, so you still a. What will gonna happen? What will be the remaining unit production here, which is z to m as well as y to c. So those are the productions that we need to solve first. So what is for z? Z is still m. Z is m and m is already a. So we can also solve this one. Since m is equals to a, therefore for z to m, it will become a. Y is equals to a, so therefore the terminal will be a. Okay, so we have to update the production rule, but it will become s is to xy. It's okay for the start state, that's fine. That's not considered as violation. What will gonna happen here? X is equals to a, and then y is to z stem with b product. Then z is to a, and then afterwards m is to a, and then afterwards n is to n. Now at this, the remaining is actually y is to z. So since y is since z is actually a, so therefore for y is to z will become a also. So what's gonna happen? We have to invite I mean So to declare also that could become S, XY, then X would become A, and then Y, Z would be, no, that's not the one. A with B, and then Z with A, then M with A, and N with A. Now we're done simplifying everything. What can we do right now? We will also remove those unreachable. What is unreachable? So for example, from your start state, since from start state you have X and Y, so therefore um, that must be um, the reachable is only X to A and Y to A and B. Therefore, Z, we cannot access Z, neither M, nor N, so therefore our answer will be this one. Decline because um, we cannot reach Z, we cannot reach um, M, and we cannot reach N. Why? Because in your S, the only accessible will be X, and X is actually A, and Y is equals to A also, or B. That's how you will work on that. We cannot access Z, neither M, neither N, no, we cannot. Those are the details. Another example, suppose that we have um, check. Okay. Now our what is the violations here? That is A is to C and B is to D. Now C is equals to A and D is equals to B. So therefore, A is to C, no, C is equals to A, or A is to C will become A. Okay. Now the same here, B, D is B, or B is to D, that is B. Okay. Those are the details. So you just have to update the production rule. The production rule is S ABA, A is C, that is C is A. Wait, will become A is to A, and then for B. So for dominant will become, it is for B, that is, we don't have earlier, D is B, so that will become B for C. Now, what about C and D? They are A and B. Okay. It will gonna happen. You have to remove an reachable. The reachable right now is A, B, or A. So it will become A is A and B, and B is B and C. So we can remove this, we can remove this, so the correct answer will be this one. Hopefully, I'll be able to understand that one. Okay? Thank you so much, everybody. Hopefully, if you really understand how the process works, this is really so simple. Make sure to put a comment down below if you really understand the process. If you have questions, just make sure to also leave in the comment section, and we'll begin to discuss already different topic until the end of the video. And so I'll begin to illustrate in the front video. Most likely the Chomsky normal form already, since we're able to discuss the cleaning up the context freedom. Okay, see you there then. And after the Chomsky normal form, I'll begin to discuss as well as those writing or grammar and regular languages, those GNF, gearbox normal form, and then hopefully we can discuss also the pumping lemma for the context-free language. And of course, we'll begin to make sure that we can also discuss the push-down automata, those instantaneous description, those acceptance models, nodes, I mean, and this deterministic push-down automata, if ever we can have it. Then the context-free grammar, convert to the push-down automata, and push them open up that context for them. Eventually, I'll begin to provide for those cases so that it will be easy for you to manage to study for those cases. Okay. Thank you so much, everybody. I'm still fixing for the presentations for those cases. Thank you and have a great day then.